Hi, I'm Craig Cogger. I'm a soil scientist and I work at Washington State University. And this afternoon we're going to learn how to estimate soil texture by hand. Farmers have known for thousands of years that there's a connection between the way a soil feels or its texture and how that soil is to be managed as farmland. Because texture, or the different size particles that we have in the soil, affect the way that water moves through the soil, the way that the soil holds water, the way that the soil holds nutrients and contaminants. So if we understand the texture of our soil, we can become better gardeners and better farmers by knowing how to better manage our nutrients and irrigation. Okay, I've taken a sample of topsoil from our farm here, and I'm going to grab a handful of that, actually about the size of a ping pong ball or a California strawberry, to use for estimating the texture of the soil. Now this sample, as it is taken from the field, is too dry to estimate the texture. You can see how it crumbles when I work it in my hand, cracks and crumbles. We're not going to be able to get a good sense of the texture. So I'm going to add moisture, and my goal is to get this about the consistency of silly putty. If I were to add too much water to it, it would no longer hold together very well. It would start sticking to my fingers and it becomes more like a mud pie. At this point, it's too wet to do texture with. You can see all the moisture on my hand. You can see the moisture just about ready to drip out of that soil sample. So what we want is silly putty and not a mud pie. Okay, now that we have the sample about the consistency of silly putty, we're going to estimate the amount of sand and silt. And this is pretty easy. I make a thumbprint in it like I was doing a thumbprint cookie, and then I rub my thumb over it. And I ask myself, does it feel gritty or does it feel smooth? If the soil feels gritty, that indicates there's a lot of sand in the soil. If it feels smooth like flour, that indicates there's a lot of silt. Sand particles are the largest of our particle sizes in the soil outside of rocks. And sand is what gives soil good drainage. Silt particles are smaller than sand, and soils with a lot of silt don't drain so well, but they tend to hold more water. A soil that has a loamy texture is a mixture of sand and silt. It doesn't feel particularly gritty or particularly smooth. This sample here has what I would call a fine grit to it. So this would be a fine sandy soil. Okay, the next step is to estimate the amount of clay in the sample. The clay particles are the very smallest ones, and they're again responsible for water holding capacity, also for the ability of the soil to hold nutrients. They also tend to help hold the soil particles together and provide some resistance to erosion. The way that we estimate the clay is we make a sculpture, much as an artist would make a sculpture. And over the years, soil scientists have tried various kinds of sculptures like worms and wires and snakes, but the one that we found that works the best is called a ribbon. So I have my sample here, and I'm going to show how to make a ribbon. As I hold it in my hand, it's a little bit elongated, and then between my thumb and forefinger, I'm going to push and lift. And notice how I actually lift the sample after I push. We can see when I make the ribbon that my thumb and forefinger are perpendicular to each other. And at some point the sample will fold over or it will break. The length at which it folds over or breaks is proportional to the amount of clay in the sample, so that we can use the ribbon length to estimate how much clay is in the sample and how that's going to influence the properties of the soil. The ball holds together well. I can make a short ribbon, but with a ribbon less than an inch long, I have less than about 10% clay in this sample. We saw earlier that it had a fine grit to it, so we would call this soil a fine sandy loam. Okay, this is another sample, and I already have it moistened to the point where it's about like silly putty. When I rub my thumb over this, it's very smooth and floury. So what does that tell us? It says we have a lot of silt in this sample and very little sand. We'll now estimate the amount of clay. So I have the soil sample here, and I start pushing and lifting. And notice how long we can make the ribbon on this one. We're somewhere between 2 and 3 inches in length on the ribbon. This sample has more than 25% clay, which means that clay is playing a major role in the properties of this soil. This is a soil that's going to hold a lot of water, it's going to hold a lot of nutrients, but it will drain water very slowly. Runoff could be an issue for this soil, and in the springtime it will take a long time for this soil to dry out and warm up enough to be ready for farming or gardening. Okay, this sample obviously is too dry to hand texture right now, so I'm going to add some moisture to it and work that into the soil. I can already tell, just as I'm working this up, that there's a lot of grit in this sample. And my thumb test tells me that it's quite gritty, so I know that this is a sandy soil. We'll now estimate the amount of clay in this sample. And so I'm pushing and lifting, the same technique as before, index finger perpendicular to the thumb. And we can see that although there's a lot of sand, there's also quite a bit of clay in this soil. The ribbon is about 1.5 inches long. We probably have about 15% clay in this soil. And that's really a great amount of clay, enough to hold water, but not enough to really slow down the drainage of water through this soil. So this would be a good soil for your garden in that it would drain water in the spring, but hold some water in the summer so that you would not have to be irrigating all the time. Okay, now texture of the soil is fixed. It's very hard for us to manipulate soil to change its texture in any area much larger than the raised bed of a backyard garden. The reason for that is if your soil has a lot of clay in it, you would have to add huge amounts of sand to change the texture. If your soil had very little clay, it would be hard to mix clay in uniformly with the sand. So that rather than try to change the texture of a soil, we usually try to modify its properties by adding organic matter to the soil. The organic matter both helps with the drainage of soil and with the water holding capacity. After texture, structure is one of the most important physical properties of the soil. And I'll take a sample of soil here and we'll be able to see some of the structure in it. You see the aggregates of soil, these little balls of soil that range in size from grains of sand up to peas, BB shot, some a little bit larger. These aggregates are important because between them are large pores where plant roots grow, where water moves through the soil, and where oxygen can move through the soil. So structure modifies the texture of the soil in allowing better water movement, better infiltration of water and air into the soil. Structure is created by the microorganisms that live in the soil. So if we add organic matter to the soil, either by growing plants and letting the residues of the plants decompose, or by adding amendments such as compost, we will feed the microorganisms and we will build the structure of the soil, making it a better environment for plant growth.